Hi there, class. Welcome to our last video lesson. I believe section 14.3 is the concluding section of our class. It's been great working with you. This is geometric sequences and series. And this idea, as opposed to the arithmetic sequence where you add the same amount each time or subtract the same amount each time, here we are multiplying by the same amount each time. For example, this first term is 3, our next term is 6, our next term is 12. What are we doing each time? Well, we're doubling each time. We're multiplying by 2. Same as last time, if I am at term number 1 and I want to get to term number 10, R is our common ratio. Ratio is the idea of the multiplying. How many times do I have to multiply the first term by R to get to the 10th term? And it's not 10, is it? It's 9. I don't count the first one because I've already taken it. So that's why we have this n minus 1. So we're repeatedly multiplying, and repeatedly multiplying means we can use exponents. So if I want to find, I could just list this right out, right? 3, 6, 12, 24, 48, 96, 192, and I even start to lose steam there, right? Or we could say that our 10th term is going to be my first term times a whole bunch of 2's. How many 2's? 9 of them. That's going to be 3 times 2 to the 9th. As everyone knows, especially those that play 2048, 2 to the 9th is 512. And 3 times 512 is 1536. So it looks like 1536 is my 10th term. All right, now what if I wanted to add those together? Well, interestingly, the formula for a specific number of terms, like 10, that's kind of a difficult one to figure out. And it takes a long time to explain well. And I think that's why they're just not covering it. But what is a very simple thing to do right here, just add those terms together. The formula is complex, but this idea right here is really bizarre, yet the formula is fairly nice and elegant. Elegant, yeah, I said that. Infinite geometric sequence. What? Series. So we're really going to add together an infinite number of numbers? Are you telling me that I can add together an infinite number of numbers and get something that isn't infinity? I want you to consider this idea right here. What am I doing to each of these numbers? Half then gets cut to a fourth, gets cut to an eighth. I'm actually multiplying by half. Dividing by 2, I'm repeatedly multiplying by 1/2. My R is 1/2. I want you to look at this. I'm going to make myself a box. And this right here is half the box. And then this right here is a quarter of the box. And this right here is an eighth of the box. And this is a 16th of the box. And a 32nd. And a 64th. And a 1/28th. And a 2/56th. And so forth. I can keep cutting this in half. And I just kind of keep spiraling in. And no matter how many times I cut that in half, I'm always going to have a little piece left to cut in half. But will I ever break out of this box that seems to be just simply 1? Right? Wow! That's just the coolest thing. You can actually take an infinite number of numbers, add them together, and get 1. Now, that only works if your numbers are going down. If you are multiplying by a number between 0 and 1. If you're multiplying by 2, I'm not going to tell you that 3 plus 6 plus 12 plus 24 plus 48 plus 96 plus 192 forever is going to equal anything but huge, right? But if you're adding numbers together that are part of a sequence where it's getting cut in half, or cut by a third, or cut by a fourth, or cut by 2/3, then you're going to end up with a nice, simple, finite number. And it's according to this formula. And I don't think you can use Desmos. I don't think there's an infinity button. But the sum of the infinite number of terms is 1 divided by 1 minus r. Sorry, I think it's a1. My bad. I really should look this up. a1 divided by 1 minus r. And let me, I'm sure that's, I don't even know where my book is. Oh, it's down here. And that means then, whatever you end up, a1 divided by, woohoo! I'm right. So whatever our first term is, whatever our common ratio is, put those in there, evaluate that, and that will give you the sum of all of them. And again, that is only for R values, I think between 1 and -1. If R is anything bigger than 1, ain't going to work. If it's less than -1, it's not going to work. And that's it. Again, there's several word problems within this that are a little bit confusing. Feel free to give me a holler, and I look forward to seeing you in the email. See ya.